Welcome to the Sleepy Club, a place where we blend the calm of a bedtime story with the excitement of learning something new. Tonight, we're venturing into a question that has fascinated humanity for centuries. Where does space end? At first, it might seem like a question with an obvious answer, but the more we think about it, the deeper we dive into the unknown, the more it opens up, like the vastness of the universe itself. As we explore this mind-bending idea, I hope it helps you relax, unwind, and drift into sleep. Or at least, give you something peaceful to ponder as your day fades away. If you enjoy these gentle journeys into knowledge and rest, don't forget to subscribe so you can join me on more sleepy explorations. And if you'd like, share where you're tuning in from. It always brings me so much joy to see our community of sleepy explorers spread all around the world. Now, get comfortable. Take a slow, deep breath in and let it out gently. Let your body settle into the calm of the night and let your thoughts quiet as we begin our journey into the vast and mysterious unknown. Ready? Let's begin. Let us begin by contemplating the true nature of the great dark expanse that reveals itself when we turn our eyes toward the distant stars. For many of us, this vastness feels like a simple absence, a hollow place where celestial bodies drift. And even those small, everyday things like lost socks seem to disappear into its depths. Yet, as we look closer, we find that space is far from being a vacant hole, for it is actually one of the most vibrant, secretive, and misunderstood elements of our entire existence. Long ago, in the time of the great scientist Isaac Newton, people imagined the heavens as a rigid and unchanging stage. In this vision, the universe was like an ancient theater with a solid, flat floor, where the planets and stars played their roles upon a surface that never shifted or sighed. It was believed to be a fixed grid that held everything in place, where time moved with a steady, unyielding rhythm for every living soul. Then a thinker with a restless mind and wild hair named Albert Einstein arrived to invite us into a more graceful truth. He dissolved that old, tidy image and replaced it with something far more mysterious and elegant. Einstein taught us that space is not a passive container at all, but is instead a living, flexible fabric that we call spacetime. This cloth of reality bends and sways, reacting to the heavy presence of suns and the dance of energy that moves through it. To feel this truth, picture a flexible surface much like a trampoline, where a heavy bowling ball is placed in the center and causes the fabric to dip. When you roll a small marble across this surface, it does not move in a straight line, but instead follows the gentle curve of the hollow. This is how we truly experience gravity, for we are not being pulled toward the earth by a magnet, but are instead rolling gently into the curves that the world has made in the fabric of the night. You may wonder if the deep gaps between the furthest suns are truly empty when no matter is present. But the truth is that even in the most silent and lonely corners of the universe, there is a profound sense of activity. Through the lens of quantum mechanics, we now see that the void is never truly vacant. At scales so tiny they are smaller than any atom, space is humming with the secret life of what scientists call quantum fields. These fields are not objects resting within space. They are the very substance of space itself, and every tiny particle in existence rises from them like a wave from the ocean. A single electron is a flicker in its own field, and a photon is a ripple in the electromagnetic sea. Even when there are no particles to be seen, these fields are never completely still, as they tremble with a constant quiet energy. They create tiny, momentary sparks of existence that appear and fade like cosmic fireflies in the twilight. This restless and hidden spirit is what we call vacuum energy, and it is much like the surface of a sleeping pond. From a distance, The water looks perfectly calm, but if you look very closely, you will see the tiny ripples, the small disturbances, and the occasional jumping fish. What seems smooth and empty from afar is actually a garden of hidden motion and potential. In this space, virtual particles emerge in fleeting pairs, only to vanish back into the mist of the unknown. Though they cannot be seen with our eyes, we feel their touch in the way electrons dance around the heart of an atom, and in the vast force of dark energy that pushes the galaxies further apart. So, we must remember that space is not just a place to lose our keys, or to send our quiet thoughts during an awkward conversation. It is alive with its own structure and movement. Even when there is nothing visible to the human eye, it becomes even more fascinating when we consider that space itself has the power to expand. This is not merely the things inside it moving away, but the very cloth of the universe stretching and growing between them. This idea is a foundation of our modern understanding of the cosmos, and it comes from those same graceful theories. It is natural to feel a sense of wonder, or even a slight fatigue, when thinking that the emptiest parts of existence are actually humming with energy and geometry and invisible fields. Yet, there is a deep comfort in this knowledge, for it means the universe is not a cold or lonely void. Even in the quietest and darkest moments, there is still something happening. A soft background mumble that sounds like the gentle crackle of a fireplace or the sigh of wind through the leaves on a still night. This restless vacuum is a reminder that space is a physical entity with its own warmth and its own song. It can stretch, it can ripple, and it even carries a temperature, for even the vast reaches between the stars are warmed by the leftover glow of the great beginning of time. When we ask what space is, we are speaking of a rich and structured fabric that weaves every atom and every galaxy into a single story. Space is not just the stage where life happens. It is one of the most beautiful things that is happening. The more we listen to it, the more it refuses to be empty, as it twists and hums and grows with every passing moment. And as for those missing socks, while space might not be to blame, if they did fall into a pocket of warped reality, at least they are now part of a very exclusive scientific mystery. Imagine standing on a quiet hilltop under the clarity of the night sky, gazing up at a living universe that stretches forever in every direction. It feels as though the expanse is without end, stretching into the eternal and reaching toward the infinite. However, there exists a cosmic boundary to all that your eyes can behold, a soft celestial bubble that wraps around us like a cocoon. This is not a sign that the universe has reached its final edge, but rather a reflection of the fact that light simply has not had the time to travel to us from the regions beyond. This is the reality of the observable universe, the specific portion of the vast cosmos that our instruments can truly detect. Whether it is the ancient light of stars, the hum of radiation, or the ripples of gravitational waves, it includes anything that has managed to make the journey to our shores since the dawn of time. That word, observable, holds a very deep meaning, for it does not imply that the world outside this bubble is empty or non-existent. It simply reminds us that we have not yet been fortunate enough to see those distant places, as they remain hidden from our view for now. One might assume, with a sense of simple logic, that the furthest we could ever peek would be a distance of 13.8 billion light-years. This seems right, because that is the age of our universe, give or take a few 100 million years of ancient history. If light travels at its own steady and unwavering speed, one would think that this would be the natural limit of our vision. Yet, the universe is far more mysterious and less straightforward than we often imagine, because space itself has been stretching and growing since the very beginning. that boundary is actually located much further away than we expect. The observable universe we inhabit today has a radius of about 46.5 billion light-years in every single direction, which means it spans 93 billion light-years from one side to the other, even though the cosmos has only existed for 13.8 billion years. The distance to the most remote galaxies we can see is more than 3 times that number. This is possible only because space has been expanding during the entire journey of the light. To help your mind drift into this concept, imagine placing small raisins onto a fresh loaf of dough before sliding it into a warm oven. As the bread begins to rise, the raisins naturally move further apart from one another as the dough expands. Now, imagine a tiny photon of light is sent from one raisin toward another, just as the baking process starts. By the time that light finally reaches its goal, the bread has grown significantly in size. The journey of that photon was not across a fixed or static distance, but was instead across a path that was growing longer with every passing second. The destination itself was moving further away even as the light was still in transit. And this is exactly what occurs on a much grander and more cosmic scale. This brings us to the gentle idea of the cosmic horizon, which you should not picture as a cold or hard wall. You could never fly a ship to this boundary and suddenly strike the edge of the world, like a character in a cosmic cartoon. Instead, it is more like a soft and gradual fading of information into the mist. Beyond this horizon, the light from those distant places has simply not had enough time to reach our eyes since the moment of the Big Bang. It is as if we are standing in the center of a vast and quiet fog, where we can only perceive the glow of things that are nearby. The rest of the universe is shrouded in shadow, not because it lacks existence, but because the signal has not yet been given to us. This horizon marks the edge of our observable slice, and it is a boundary that is constantly shifting and changing. As time flows forward, light from even more distant regions will eventually arrive, and our bubble will continue to grow larger. At the same time, because the expansion of space is accelerating, some galaxies are drifting away from us with such incredible speed that the light they emit today will never reach us. Not even in trillions of years will that light find its way home. For those distant worlds are receding faster than light itself. They are not breaking any cosmic rules of speed, but instead, the very space between us is stretching too quickly to be crossed. In a very real and poignant sense, the universe is slowly slipping out of our gentle grasp. Let us take a quiet pause now to appreciate the beauty of what we can still see. Every single star, every swirling galaxy, and every faint smudge of light in the night sky remains within our observable bubble. This is a wonderful gift, even if there is almost certainly much more beyond our reach, perhaps even an infinite expanse that we will never touch or study. We are cradled by a vastness that is far greater than our instruments can measure, yet we are permitted to peek through this small window of perception. What is even more humbling is the thought that every being, in every place, possesses their own unique observable universe. If you were standing on a galaxy 10 billion light-years away, your cosmic bubble would overlap with ours, but it would also hold secrets that we will never know. The observable universe is not the whole of existence, for it is simply our own beautiful and private slice of the cosmos. And what a magnificent slice of existence it is, containing roughly 2 trillion galaxies, where each one is filled with millions, or even trillions of radiant stars. All of that immense starlight is gathered into our modest observational bubble, like a collection of precious gems held within a soft and glowing light. The photons from some of these distant galaxies have been traveling through the deep silence for billions of years, only to find their final rest against your retina, or upon the delicate sensor of a telescope. There is a profound wonder in knowing that some of this light began its long journey, even before our very Earth had taken shape. This ancient glow serves as a kind of celestial time machine, a quiet message in a bottle sent from an epoch that has long since passed into shadow. Yet, as vibrant and rich as our observable universe appears, it may be only a tiny and flickering fraction of the total expanse. Beyond the reach of our cosmic horizon, space might stretch on forever, or perhaps it curves and loops back upon itself in a strange multi-dimensional geometry that our minds can barely grasp. We may never truly know what lies in those furthest reaches, for no light or signal, bound by the slow speed of causality, can ever cross that divide to reach us. There is a certain peacefulness to be found in this sacred limit, a quiet reminder that our place in the great design is fundamentally local. We do not need to possess the keys to the entire universe, or understand every hidden corner, to find a deep and lasting meaning in our lives. Sometimes it is enough to simply rest beneath the canopy of stars and feel the comforting weight of being part of something so much larger than ourselves. Though 93 billion light years sounds like a massive distance, it is truly just the visible frosting on a cosmic cake that is unfathomably vast. What exists beyond our sight is a mystery that invites only our softest guesses. Perhaps more galaxies, or more structures of dark matter and dark energy, or perhaps something even more enchanting and strange. For now, we are content to drift within our glowing bubble of light and information, and a home shaped not by cold borders, but by the patient journey of ancient photons. This bubble is not a prison that keeps us in, but is instead a gift, a slowly expanding window that allows us to look deeper into the story of existence with every new day. When we gaze up at the velvet night, we often imagine that we are seeing the universe as it exists in this very moment. Yet that is not quite the truth of it. What we are truly witnessing is the universe as it once was. For every star and every glowing dot is a beautiful time capsule from the past. Looking across the great expanse is like gently rummaging through a cosmic attic, where each layer of light pulls us further back into the history of all things. Consider for a moment the humble light year, which is the distance that light can travel in a single year, covering about 6 trillion miles, or nearly 10 trillion kilometers. When your eyes catch the light of a star that is 100 light years away, you are seeing it as it appeared when your great-grandparents were still young and full of dreams. As we stretch this idea across the vastness, we find that some galaxies are billions of light years distant, meaning their light began its race before our solar system was even a thought, long before the Earth had formed its deep oceans, or nurtured its first tiny sparks of microbial life. That light was already rushing through the dark toward a future observer, toward you. This brings us to a concept known as look-back time, a way for us to measure how far into the ancient past we are peering when we observe the heavens. If a galaxy sits 8 billion light years away, we are seeing it as it was 8 billion years ago, as its light has been traveling for more than half the age of the entire universe. That light arrives just in time to grace your evening of stargazing, or to land softly on the mirrors of a telescope that orbits far above our world. In a strange and haunting way, the space above us is full of ghosts and shimmering echoes of what used to be. We are not seeing the galaxies as they are today, but are instead seeing them frozen in the earlier chapters of their long and winding stories. Some of those distant worlds may no longer exist at all, for they might have merged with others, or run out of the gas that once sparked new stars. Some may have simply drifted beyond our reach, carried away by the relentless expansion of the universe into the unknown. What we behold when we look at the stars, is a cosmic fossil record, a history of the heavens written entirely in the soft and steady flow of ancient photon. As light wanders through the expanding heart of the universe, it begins to stretch, a beautiful phenomenon that we call the redshift. Much like how the tone of a passing siren falls away as it moves into the distance, the very wavelength of light grows longer when its source drifts away from us. Because the fabric of space itself is forever growing, nearly all the distant galaxies are receding, and the light they send toward us becomes stretched into longer and redder waves. By observing the subtle shift in these colors, the watchers of the sky can discover how far a galaxy has traveled, and even more importantly, how long that light has been on its lonely path. A high red shift is like a deep sigh from the early universe, offering us an ancient glimpse into the beginning of all things. This light, tinted by its long journey, holds the secrets of the structure, the age, and the very history of our cosmos. It whispers to us of how quickly the universe is expanding, how galaxies slowly find their form, and even hints at the silent forces of dark energy that shape the world on a grand and invisible scale. Every photon that has changed its color is a tiny messenger from the deep past, carrying encoded stories of where it came from and what the universe was like back then. Let us turn our thoughts to telescopes, those wonderful cosmic time machines that allow us to travel through the ages without ever leaving our home. When you peer through these lenses, you're not merely seeing the stars more clearly, but you're reaching deeper into the layers of time itself. A small telescope in your own garden might show you the swirling clouds of Jupiter as they appeared 40 minutes ago, while a more powerful eye could reveal a galaxy as it looked 500 million years in the past. This was a time when life on our own world was still experimental, a time of fins and gills beneath the ancient seas. Then there are the true heavyweights of the sky, the great observatories like Hubble and James Webb, along with the silent successors waiting in the wings. These instruments can look so far into the distance, and thus so far back into the deep reaches of time, that they capture the faint light of the first galaxies to ever form. We are witnessing the birth of structures that began to breathe just a few 100 million years after the Big Bang first echoed through the void. It is a gentle irony that in our quest to understand the future of the universe, we must spend most of our time staring into the distant mirror of its past. This is the true nature of light, for while it travels with incredible speed, it is not instantaneous, and the universe is so vast that even light has to work hard to bridge the gaps. This means that the universe as we experience it is always a little bit out of date, much like watching a film that is still being edited with scenes arriving one by one and out of their proper order. Some scenes come from the galaxies that live just next door, while others travel to us from across the deepest cosmic abyss. Yet, this delay is a magnificent gift, for without it, we would never be able to piece together the story of how everything came to be. The slower arrival of this ancient light allows us to see different stages of the universe's evolution all at once, like pages torn from a novel and scattered across the sky. The result is a beautiful patchwork of time where, in one direction, we might see a relatively nearby galaxy that formed recently, while in another, we glimpse a flickering light from billions of years ago. These are times when stars were still forming from clouds of primordial gas, and all these images are layered not just across space, but across time itself. You could say we are living inside a museum made entirely of light, but instead of walking from exhibit to exhibit, we let the photons come to us. They cross unimaginable distances to tell their stories, and to fill our sky with ancient news from the dawn of everything. There is something quietly poetic about the idea that every time you look up, you are gazing into a time machine. The light brushing against your eyes may have started its journey before the first tree on Earth, before the first breath of our atmosphere. And before the first breath of our atmosphere. All of these insights come from simply listening to the light, and by studying its colors, its shifts, and its age, we unlock a silent language spoken across billions of years. This language does not merely describe the universe. It is the universe itself, encoded in the quiet motion of the stars and the deep memory of the void. Next time you see a star twinkling in the night, remember that you are not looking at it as it exists now, but you are looking at a version of it preserved forever in time. It is a glimmer of history still racing through the darkness, showing us what the cosmos looked like when it was younger, smaller, and perhaps even gentler, through the lens of our science, and with the patient help of ancient light. We continue to piece together our own origin story, one distant glow at a time. Imagine yourself standing in a wide field, early in the morning, where the grass is still wet with dew, and the air is cool against your skin. A soft fog rolls gently across the horizon, allowing you to see only a short distance ahead, perhaps a few trees, or the outline of a distant hill. Beyond that veil, everything fades into a pale and quiet blur, and though you know the world continues past the fog, your vision cannot reach it just yet. In a way, this is what it is like to live inside the universe, for no matter how powerful our telescopes become, there is always a limit to how far we can see. This limit is not caused by fog in the traditional sense, but by the mysterious nature of time, distance, and the peculiar nature of the expanding cosmos. These boundaries are what we call cosmic horizons, and they define the very edges of our observable universe. Unlike the tidy horizon on Earth where the sky meets the land, these cosmic limits come in different forms, each with its own significance. The first is known as the particle horizon, which represents the maximum distance from which light or any other signal could have reached us since the universe first began. It marks the outermost edge of our current cosmic bubble, a perimeter shaped by the 13.8 billion years that the universe has existed, because space has been expanding during all that time. The furthest distance light could have traveled to reach us today is about 46 billion light years in any direction. This makes the observable universe roughly 93 billion light years across, a grand perimeter of everything we can currently detect. We must not mistake this horizon for a solid wall, for there is no border or glowing edge with a sign that says no entry. Instead, it is a limit woven into the very fabric of time, like standing on the shore of a vast sea, where you look out as far as light allows. You will never see beyond that gentle curve, not because there is nothing there, but because the signals have not yet had the time to arrive. Next, we come to the event horizon of the universe, which is a different kind of boundary than the one found around black holes. In the study of the stars, the event horizon is the line beyond which events can never affect us. No matter how long we wait, it is a cosmic line drawn in the sand, for anything beyond this point is retreating from us faster than the speed of light due to the expansion of space. That light, no matter how persistent or patient it may be, will never be able to catch up to us. It is like trying to send a message to a friend on a raft, floating away down a river, where you throw a bottle with a note inside. If the current is so strong that the raft drifts faster than the bottle can float, your message will never be delivered. This is the event horizon, where communication and light itself become impossible, and at this moment, it is thought to be about 16 billion light years away. This means there are regions of the universe we can see now, but if they emit new light today, that light will never reach us. We are watching galaxies that are, in a very real sense, slipping away, visible today, but destined to fade from our view forever. Finally, we have the cosmological horizon, a term that encompasses these observational limits and reminds us that they are deeply tied to the physics of the universe itself. It can be thought of as the moving edge of the observable universe, expanding outward as time goes on and light from more distant objects has the chance to arrive. These horizons are constantly shifting and evolving as the universe continues its long and quiet journey through the ages. As the universe grows older, the particle horizon continues to expand, and more light is given the time it needs to reach our eyes. But because of the presence of dark energy and the accelerating expansion of space, the event horizon begins to shrink in its relevance. More and more galaxies are drifting beyond our reach, and the universe is slowly becoming a place of increasing isolation. This is not because the cosmos is becoming empty, but because the light from its most distant corners is falling behind in a race it can no longer win. To think of it in another way, the universe is like a slowly inflating balloon, where dots upon its surface drift further apart as the skin of the balloon stretches. The farther these dots are from one another, the faster they seem to move away, and we can only see those that are close enough for their light to complete the journey. Beyond that point, the light is stretched and dimmed until it finally vanishes into the expanding abyss of the night. There is something haunting, yet deeply peaceful about these limits, for they serve as a quiet reminder that we are not omniscient observers of all that exists. Our view of the heavens is shaped by cosmic history, by how long light has been traveling, and by the strange and fluid properties of the space it must cross. We are peeking through a window that is indeed enormous, yet it remains fundamentally finite and precious. Some regions of the universe will always remain a mystery to us, no matter how patient or clever our minds may become. This is not due to a lack of technology, but is woven into the very nature of space-time itself. These unseen realms are not hidden behind a curtain waiting to be pulled back, but are instead beyond the reach of information, forever unknowable to our senses. And yet, even within these soft boundaries, we have managed to learn so much about the world we inhabit. We have mapped the distant galaxies, measured the faint background radiation, and traced the ancient fingerprints of the Big Bang. We have used the fog of the particle horizon to understand the structure of the cosmos, and the glow of ancient light to piece together its long story. These horizons do not limit our imagination. They simply frame it, like the rising sun burning off the morning mist to reveal more of the landscape. Some parts will always remain hidden behind the curve, behind the stretching and swelling boundary where light will never arrive. Still, here we are, spinning quietly in our own corner of the universe, watching photons arrive from billions of years ago. We read the messages they carry and dream about what lies beyond the next soft bend in the cosmic road, even if we cannot see it all, and even if parts of the universe are forever beyond our reach. There is a certain beauty in the trying. We listen to the quiet hum of light, following it to the edges of knowledge, and knowing that while we may never see the full view, we are part of the story just the same. Not too long ago, in the grand timeline of human curiosity, people believed the universe was steady and unchanging. It was thought that galaxies were simply out there, stars were shining, and everything more or less stayed in its place within a quiet and eternal cosmos. But in the early 20th century, a discovery rose from a mountaintop observatory that changed everything. And the universe has not sat still since. It was Edwin Hubble, the man whose name now graces the famous space telescope, who first noticed something peculiar in the light of the stars. While studying distant galaxies, he observed that their light was consistently redshifted, meaning they were moving away from us. He found that the farther away a galaxy was, the faster it seemed to recede, which was not a random trend, but a law of nature. Space itself, it seemed, was expanding, and this is not the same as galaxies zooming through a fixed space like cosmic race cars. They are not bursting outward into a pre-existing void, for what is actually happening is far more strange and elegant. Space itself is growing, and galaxies are being carried along with it like raisins embedded in a rising loaf of bread. This image of raisin bread is a gentle and surprisingly accurate way to picture our universe. Think of the dough as space and the raisins as the galaxies, and as the dough bakes and rises, it stretches in every direction. Each raisin finds itself farther from the others, not because it is moving on its own, but because the dough between them is expanding. There is no central raisin and no preferred direction, just a uniformly growing loaf of light and matter. This is how the universe works on a large scale, where galaxies are not rushing through space like cannonballs, but are being carried away as the fabric of space stretches. No matter where you are in the universe, it looks as though everything else is moving away from you, as if you were resting inside a rising and beautiful souffle. No matter which bubble of perception you happen to inhabit, all the other bubbles will seem to be drifting away into the soft distance. The universe is not expanding into a waiting room, or any pre-existing void. It is simply expanding. There is no outer shell to this reality, and no final edge that it is racing toward. Instead, the distances between the objects that are not held together by gravity simply grow over time, as if the cosmic measuring tape were slowly and steadily lengthening. This idea of an expanding universe was so radical when Hubble first proposed it that even Albert Einstein felt he had to revisit the architecture of his own equations. Originally, Einstein had added a concept called the cosmological constant to his general theory of relativity, specifically to make the universe stand still. He believed with his whole heart that the cosmos had to be static, yet his equations, when left to their own devices, suggested something far more fluid. When he finally heard of Hubble's findings, he famously called that constant his greatest blunder, though ironically, the idea has since made a return to help us explain the mystery of dark energy. The universe, it seems, possesses its own sense of humor and a way of circling back to forgotten truths. One of the most beautiful consequences of this discovery is that it allowed us to rewind the cosmic clock to the very beginning. If the galaxies are all moving away from each other now, they must have been much closer together in the deep past. This realization led scientists to the idea of a hot and dense beginning to our universe, which we now affectionately call the Big Bang. This name can be a little misleading, for it was not a sudden explosion in space like fireworks going off in a dark and silent field. It was more like a rapid and gentle swelling of space itself, occurring everywhere all at once without a center or a blast radius. You cannot point to a single location in the sky and say, that is where it happened, because it happened everywhere, including right where you are sitting at this very moment. That expansion is still going on today, nearly 14 billion years later, as galaxies continue to drift apart and the light they emit continues to stretch with them. Interestingly, the expansion of the universe does not affect everything in the same way. It works its magic on the grand scale between galaxies and clusters, but it does not pull your morning coffee farther from your lips or separate the atoms in your chair. This is because gravity and other fundamental forces dominate on these smaller scales, keeping our local world nicely glued together. The Milky Way is not expanding. Your neighborhood is certainly not expanding, and even your laundry pile remains relatively stable. But on the cosmic level, the expansion continues, and what is more, it has begun to accelerate. This discovery, made in the late 1990s, came as a great surprise to the world of science. It was assumed that the expansion might be slowing down due to the pull of gravity, but instead, a mysterious force called dark energy is causing it to speed up. The dough is not just rising, it is rising faster and faster with every passing moment that drifts by. No one is entirely sure what dark energy truly is, for it might be an inherent property of space itself, or a field we have not yet understood. Whatever its nature, it now dominates the energy budget of the universe, turning a gentle stretch into a cosmic sprint. There is something poetic in the way the universe began with everything close and unified, before cooling to form the stars, the planets, and all the ingredients for life. Now, it continues its outward drift, as stars age and space stretches into the unknown, like a story that blossoms in complexity and then drifts off into a gentle, infinite epilogue. If there was sound in space, perhaps it would be the soft creak of rising dough, or the peaceful hum of a universe becoming itself. When we say the universe is expanding, we are not talking about things flying away from a central point, but about the very fabric of reality, stretching as calmly as a loaf of bread in the oven. It is one of the most profound discoveries, and also one of the most comforting, offering the idea that change can be slow and beautiful. As we sit here surrounded by stars and bathed in ancient light, we are part of that very expansion. Every breath and every thought you have ever had has taken place on a little rock, spinning in the middle of this rising cosmic dough. In the world of physics, there is a hard and fast rule that is never meant to be broken. Nothing can move faster than light, not a spaceship, not a signal, and certainly no traveler on this earth. According to the theory of relativity, the speed of light is the universal speed limit, and nothing with mass can ever reach or exceed its pace. And yet, out there in the great cosmic distance, astronomers have observed something that seems to defy this very rule. Imagine galaxies that appear to be drifting away from us at speeds faster than light itself. It might seem as though entire clusters of stars and cosmic dust are slipping beyond our reach at impossible superluminal speeds. One might think that the laws of physics should be in a state of panic, yet there is no need for worry, for everything is exactly as it should be. The universe is not breaking its own rules, but is instead playing a very clever and subtle game with them. To truly understand this mystery, we must revisit that beautiful idea that galaxies are not flying through space like lonely comets in a vacuum. Instead, it is space itself that is expanding, and the galaxies are simply being carried along within its gentle growing embrace. Think of space as a soft rubber sheet with small dots scattered across its surface. If you take the edges of that sheet and stretch it, the dots will move further apart. Not because they are crawling across the material, but because the surface itself is growing underneath them. This is how galaxies can appear to recede from each other at speeds greater than light. It is not that they are breaking any cosmic speed limit, but that the space between them is stretching so quickly that the total distance increases faster than light can bridge the gap. The galaxies remain obedient and peaceful citizens of the laws of physics, while it is space that is doing all the heavy lifting. There is a helpful way to picture this in your mind. Imagine you are standing on a long treadmill that is gradually speeding up, and you try to walk towards someone at the far end. If the treadmill is moving backward faster than you can walk forward, the distance between you and the other person will keep increasing, no matter how hard you try. It is not that you are walking too slowly, but that the very ground beneath your feet is working against your motion. In the case of our universe, light is like that traveler trying to move through expanding space. In some distant regions, space is growing so rapidly that the light never makes any progress toward our eyes. It is like trying to paddle a quiet canoe upstream during a sudden flash flood, where the water flows too fast and your boat is swept further away, despite your best efforts. This does not violate the rules of relativity, because those laws only forbid objects from moving through space faster than light. They say nothing at all about how fast the fabric of space itself is allowed to grow, and as it turns out, space has a certain flair for making dramatic and sudden movements. Consider the period known as cosmic inflation. a mind-bendingly brief moment just after the Big Bang, when the universe expanded at a staggering rate. In less than a trillionth of a second, the entire universe grew from something smaller than a tiny proton to something the size of a grapefruit, or perhaps even larger. This faster-than-light swelling did not break any laws, for it was the space itself that was expanding, rather than particles racing through it. It is one of the few moments in all of physics when traveling faster than light is not only allowed, but encouraged. This rapid inflation served as a cosmic steam press, ironing away the wrinkles and unevenness of the early universe. It helps to explain why the heavens look so uniform and peaceful in every direction we turn our gaze, even though distant regions have not had the time to exchange information. Inflation spread everything out so quickly that any local differences became subtle and stretched far apart. Even now, billions of years later, we are still witnessing the lingering effects of that ancient expansion. Space continues to grow, carrying the most distant galaxies further and further away from our lonely perspective. Some of those worlds are now receding faster than light, not because they have gained speed, but because the space between us is growing faster than light can close the distance. This means that there are vast regions of the universe that we can never hope to see. No matter how long we wait with patient hearts, their light will never reach our shores. If they were to emit a new spark of light today, that light would be swept away into the deepening void of the abyss. These galaxies are not lost because they are moving too fast, but because the road between us is stretching out faster than their signals can travel. It is like trying to send a postcard across a wide river where the opposite shore is drifting away faster than you can throw. No matter how many stamps you place upon it, the message will never reach its destination, and eventually the very idea of delivery becomes a beautiful impossibility. So, when you hear that galaxies are receding faster than light, remember that it is simply the expansion of space itself. There is no violation of the laws we know, just a clever interpretation of how space and time can flex in ways our instincts do not always understand. This cosmic trick carries with it another strange consequence, for there are galaxies we can behold today through our finest telescopes that have already crossed over this invisible horizon. They remain visible to our eyes because the light they emitted so very long ago is still finishing its lonely journey to our shores. But the newer light they are producing in this very moment is already far out of our reach, and it will never find its way to us, even if we were to wait for an eternity to pass. It is a little like watching the distant tail lights of a car that has just turned a quiet corner, where you can still see the soft glow of the lamps, but the car itself is already gone. It is cruising down a hidden road that you will never be able to follow, and the light you see is merely a ghost, a message from a past that can no longer be updated or changed. This reality holds a certain peaceful melancholy within it, for the universe is full of stories we will never hear, stars we will never see, and galaxies we will never even know existed. This is not because we did not look with enough care, but because the cosmos itself is drawing a velvet curtain and stretching the stage far beyond our view. Yet, this too is part of the magnificent wonder of our existence, and the fact that we have been able to glimpse so much of the universe's history is nothing short of a miracle. Despite all the staggering distance and the distortion of space, we have still managed to see billions of light years in every direction. We have caught ancient photons in mid-flight, pieced together the humble origins of the galaxies, and even traced the faint and lingering afterglow of the Big Bang itself. All of this has happened from our home on a tiny planet, orbiting an unremarkable star in an average galaxy, within a universe where space can move faster than light. It is enough to make one feel very small, but also strangely lucky to be alive in such a time, because here we are, listening to the whispers of an expanding cosmos, watching the light struggle to reach us, and counting the galaxies as they slowly fade into the distance. And all the while, the dough of the universe continues to rise, carrying with it the dreams of curious beings who once wondered just how far light could truly go. When we think about the universe, it is very tempting to picture it like a large and silent black box. We imagine a vast rectangular space with a top and a bottom, or a left and a right, just floating in the middle of something else. We wonder if it has edges, or if it goes on forever, or if there's perhaps a giant cosmic wall with a sign that forbids entry. But the real shape of space is much more subtle and much more fascinating than a simple box. It turns out that space is not necessarily flat like the surface of a tabletop, for it might be curved in ways we are only beginning to understand. It might be positively or negatively curved, or perhaps it is just ever so gently flat. And this is not just a matter of beauty. The geometry of the universe has deep implications for how it evolved, how it behaves, and whether it might one day curve back in on itself, or continue stretching forever into the mist. Let us reflect on the three main possibilities for the shape of all things, beginning with a flat universe, which is like an infinite and perfect sheet of paper. In this model, the rules of geometry behave exactly as we were taught in our school days, where parallel lines never meet and triangles always add up to 180 degrees. If you were to travel in a straight line through such a space, you would never loop around, but would instead keep going indefinitely through an endless cosmic plane. The second option is a closed universe, shaped much like a sphere, or more precisely, the three-dimensional equivalent of a shimmering globe. In this realm, space curves back on itself with a gentle embrace, and if you were to set off in a straight line and avoid all the stars and planets in your path, you would eventually return to your starting point. Like walking in a steady line around the surface of the Earth, you would never fall off the edge, but would simply keep going in circles, though it might take several billion years and a very sturdy heart to complete the journey. The third possibility is an open universe, shaped like a vast and infinite saddle. This space curves outward in every direction, and in such a geometry, parallel lines eventually begin to diverge and move away from each other. Here, the angles of a triangle add up to less than 180 degrees. And if you tried to travel around the universe, you would never come back to where you started. You would simply drift farther and farther out into the cosmic vastness, lost in a space that refuses to close. These shapes, whether flat or closed or open, are not just abstract ideas for us to ponder, but are tied directly to the density and the energy of the universe itself. They depend on how much matter and energy exist compared to the perfect balance needed to keep the universe in harmony. This critical density acts as a silent architect, determining whether space bends inward, outward, or not at all. If the actual density of our world is greater than this critical point, space becomes closed and positively curved, like a shimmering globe. If the density is less, the universe remains open and negatively curved, much like the surface of a saddle. And if the densities match with a perfect and delicate balance, the universe is flat. Meanwhile, it is a bit like the Goldilocks of cosmology, for it is not too much and not too little, but just enough to keep the geometry straight. We might wonder how we could ever measure such a vast thing. And as it turns out, the universe has left behind clues in the cosmic microwave background. This is the ancient light that has been traveling toward us since shortly after the Big Bang. First whispered through the void. By analyzing the tiny fluctuations in this faint and sacred glow, scientists can determine how space itself bends light over unimaginable distances. It is like observing the pattern of ripples on a quiet pond to understand the hidden shape of the shore. So far, the evidence gathered by our instruments suggests something truly remarkable. Our universe appears to be very, very close to being flat. Perhaps not perfectly so, but close enough that any curvature remains too small for us to detect. It is like standing on a massive and endless plain that might have a slight bend somewhere far over the horizon, but as far as your eyes can see, the path ahead is straight and true. Now, here's where the story of space gets even more interesting, for a flat universe can still be infinite, or it might not be. A closed universe, surprisingly, can be finite but unbounded. That phrase might sound like a contradiction at first, like a mug that is full but holds no coffee, but it makes sense with a little quiet thought. Take the surface of a sphere. It is finite, meaning you can measure its total area, yet it has no edges. You can walk across the surface of a globe forever and never fall off the edge, because there is no edge to be found. The whole surface simply connects back onto itself in a never-ending embrace. Now, take that simple concept and apply it to a three-dimensional version of our world. This is what the Watchers of the Stars mean by a space that is finite but unbounded. It is a closed loop, a self-contained bubble of geometry that does not possess a border or a sign that says the end. There is no place where the universe stops and something else begins, for it is just space curving back around in a grand and subtle loop. Well, and because we live within it, we would never be able to tell directly, as we would just keep drifting forward thinking we were going straight, while quietly bending back toward home. Even in a flat or open universe, the idea of infinity brings its own peculiar and wonderful flavor. An infinite universe means an endless number of galaxies, stars, and potentially even repeating patterns across the dark. Somewhere out there, if the universe is truly infinite, there could be another version of you listening to this very same story, perhaps while wearing a slightly different pair of pajamas. It is worth noting that we can only observe a small fraction of the universe beyond our own horizon, and we do not know how space behaves in those furthest reaches. It could be flat forever, or it could curl into a loop that we are simply too small to detect. The curvature might be so slight that even a beam of light traveling for billions of years does not reveal its secret. It is like trying to tell whether the Earth is round while standing in the middle of a wide meadow, where you do not see the curve, but it is there all the same. This cosmic geometry also affects the final fate of our universe. In a closed universe, gravity might eventually slow down the expansion and cause everything to contract once more, leading to a big crunch. In an open or flat universe, the expansion could continue indefinitely, thinning out all matter and cooling the cosmos into a gentle and quiet fade, with dark energy pushing things apart ever faster. A big crunch seems unlikely based on what we know today. But what is particularly comforting, in a quiet kind of way, is that no matter the shape, we are a part of it. Whether the universe loops or drifts, curves or stretches, we are woven into its very structure. Our atoms obey its geometry, our light traces its curves, and our thoughts echo through its vast and silent halls. We do not just live in space. We are space folded into itself in a dance of mass and motion. So, if the universe is flat, we live in a grand plane of cosmic possibility. If it is curved like a sphere, we may be looping around inside an invisible and protective bubble. If it is open, we are surfing an endless saddle, heading out into infinity with no round-trip plan. Whichever version is true, it is strange, elegant, and beautifully confusing in just the right measure. And that, in itself, is part of the magic. One does not need to pin down the exact shape of space to appreciate its deep and lasting mystery. You can simply gaze up at the night, smile at the distant stars, and know that you are standing on a tiny patch of something truly grand and curious. It is a universe with a shape we are still trying to imagine from the inside out, much like a tiny creature living on the surface of a colorful balloon. Imagine you are that creature, walking north, south, east, and west along the surface, but unable to dig down or float above the skin of your world. Your entire existence is that two-dimensional surface, curved but seamless, where you do not know the balloon is being held by a giant cosmic toddler. You only know that when you walk in what feels like a straight line, you eventually loop back to exactly where you started. This is the quiet magic of curved space, playing by rules that do not always match our everyday experience, yet making perfect sense once you slip into its rhythm. While we humans live in 3 dimensions of space, looking at curved surfaces in 2 dimensions gives us a surprisingly useful way to imagine what our universe might be doing on a much grander scale. Let us start with something simple, such as a flat surface like a sheet of paper, or a calm tabletop, where geometry behaves in familiar and comforting ways. You can draw a triangle there, and the angles will always add up to 180 degrees. And if you draw 2 parallel lines, they will never meet. If you start walking in a straight line, you will keep going forever, unless you hit a wall, or perhaps an unfortunate coffee spill. But now, imagine walking on the surface of a sphere, such as a planet or that balloon we mentioned earlier, where geometry starts acting a little strange. If you draw a triangle using great circles, such as the equator and lines of longitude, you will find that the angles can add up to more than 180 degrees. Parallel lines do not stay parallel for long, as they converge at the poles, or drift apart depending on the path they take. Most importantly, if you walk in a straight line on this curved surface, you will eventually come back to where you started without ever turning around. There are no edges and no borders, just a continuous and peaceful loop. From your limited perspective on the surface, the space around you feels infinite, but in reality, it is finite and curved back on itself. Now, take that concept and scale it up in your mind to a 3-dimensional version of that balloon surface. Except instead of curving in 2 dimensions, it is curving in 3, or rather, in a way we cannot easily visualize because it curves into a higher dimensional space. You and I live inside this 3-dimensional space, moving through it without ever seeing the outside. Just like the balloon creature never sees the air around its world. In this analogy, the galaxies are like small dots drawn on the surface of the balloon, and as the balloon inflates, the dots move farther apart from one another. This is not because they are crawling across the surface, but because the surface itself is stretching and growing. This is what the Watchers of the Sky mean when they say the universe is expanding. For it is not that galaxies are flying through space like comets on holiday. It is that space itself is growing, carrying the galaxies along with it in its gentle expansion. And just like our little balloon creature, if the universe is truly curved and finite, then traveling in a straight line long enough might eventually bring you right back to where you began. You would not fall off the edge of space because there's no edge to be found. As the loop closes smoothly and perfectly, it is a finite space with no boundary. A strange and lovely idea where you could go on an infinite journey through a finite universe, never hitting a wall and never running out of room. The balloon analogy also helps us understand why there is no special center to our universe. Just as there is no single center on the surface of a balloon, the universe does not have a central point from which everything is expanding. The expansion happens everywhere at once, and every point on the balloon moves away from every other point as it inflates. You could pick any spot in the cosmos and call it here, and the view would look the same in all directions. It is worth pausing to note that the balloon analogy is not perfect, for it is just a model to help our 3-dimensional brains wrap around a higher dimensional idea. The balloon surface is 2-dimensional, and embedded in three-dimensional space, which we can see and picture quite easily. But if our universe is curved, it might be curved in a higher dimensional space we cannot observe directly. It is not floating in a larger container, for space does not need an outside in order to curve and grow. Space can curve intrinsically by its own properties, needing no reference to anything external to define its form. This idea of intrinsic curvature is one of the grandest insights of Einstein's theory of general relativity, showing us that space and time are not merely a passive backdrop for existence. Instead, the fabric of the cosmos has its own shape and structure, a form that can evolve and change as the ages pass. Mass and energy act as the guides that tell spacetime how to curve, while the resulting curvature tells matter how it must move. It is a beautifully circular relationship, one that governs everything from the steady orbits of planets to the majestic behavior of galaxies on the largest scales. The curvature of space also touches the very path of light, for in a curved universe, light does not travel in the simple straight lines we might imagine. It follows the shortest path available to it, a trajectory called a geodesic, which is like a great circle drawn upon the surface of a sphere. In our universe, light follows a curved path that bends under the influence of gravity and the very shape of space itself. This is why massive objects, such as stars and black holes, can bend the rays of light as they pass by, a phenomenon we call gravitational lensing. When we gaze out at the night sky, we are not just seeing objects scattered through a flat and empty void. We are witnessing a delicate web of light moving through curved space, stretched and bent and shaped by the mass of everything it encounters. It is much like looking at the distant stars through a slow-moving funhouse mirror, where the distortions reveal a deep truth about the shape of the cosmos. Let us return to our quiet balloon one last time, observing how the distances between the galaxies on its surface grow as it inflates. Even as the space between them expands, the galaxies themselves do not grow larger, for they stay the same size through the long journey. This is because the expansion of space happens only on the grandest scales, between objects that are not held together by the pull of gravity. Our own Milky Way, our solar system, and even the familiar coffee shops of our world are not getting stretched like taffy. The expansion only takes hold in the great and lonely emptiness between the galaxies. We now believe that a mysterious presence called dark energy, which is inherent to space itself, is causing the universe to accelerate in its growth. It is as if the balloon is not just inflating, but is doing so faster and faster with every breath of cosmic time. We do not know exactly what dark energy is, but we can see its effects in the way distant galaxies drift and how ancient light spreads across the heavens. This leaves us living in a space that might be curved, that might be finite yet boundless, and expanding yet without a center. It is a world shaped by rules that defy our everyday experience, yet make perfect sense in the grand and silent cosmic dance. All of this, the curves, the expansion, and the possibility of looping back to our start, can be imagined with a simple balloon. It is a rubbery metaphor floating through our thoughts, whispering ancient secrets about a universe that grows not outward from a point, but within its own heart. Next time you see a balloon rising into the sky, give it a little nod, for it carries within it the shape of something much greater. It represents a gentle curve, a stretch of space, and the quiet idea that the place you are headed might be the place where you first began. Infinity is a word that feels as though it should echo when you say it, for it is vast, mysterious, and perhaps a little intimidating to the mind. It conjures images of endless stars, limitless space, and the kind of deep questions that make us pause and wonder about our place in all things. We ask ourselves if the universe is truly infinite, if space is unending and stretching on forever without a final border or a wall. So far, everything we have measured about the large-scale structure of our world suggests that it might indeed be infinite. Observations of the cosmic microwave background, the faint afterglow of the Big Bang, reveal that space is extremely close to being flat. It is not bumpy like a sphere or curved like a saddle, but flat in a geometrical sense, and in the context of our theories, a flat universe could very well be an infinite one. If the universe is not infinite, it is at least much, much larger than the small portion we are permitted to observe. This leads us to the observable universe, that cosmic bubble stretching 93 billion light-years, across which we can see. This is the part of the cosmos we have access to, because light from those regions has had enough time to reach us since the beginning of time. But beyond that edge, the universe could keep going forever, with galaxies upon galaxies and cosmic structures we will never detect. There may be entire regions of space that are forever beyond our view, and we cannot truly prove or disprove whether the universe is infinite. We are confined by our observational limits, much like tiny ants on a wide beach, looking in every direction and seeing only the familiar sand. For all we know, the beach stretches across an entire continent. Or perhaps it ends just a few dunes away in a tide pool full of life. We simply cannot see far enough to know, for infinity is not a number we can measure with a ruler, but a vast quality of the space we call home. Infinity is not a number we can count to, but an idea, a concept that exists as a vast whisper in the mind of science, in the world of evidence and reason. Concepts need a foundation to rest upon, yet infinity is a slippery thing that can never be directly observed. One can only search for the quiet signs that space shows no intention of curving back on itself, or ending abruptly, or behaving in a way that suggests it forms a loop. So far, we have turned our gaze in every direction, and found no detectable edge, no sudden drop off into a void, and no cosmic fence with a sign telling us to turn back. This does not mean that a border does not exist, for it simply remains beyond the reach of our current vision. Unless we were to invent a telescope capable of outrunning the very expansion of the universe, this mysterious horizon is unlikely to change. The idea of an infinite universe brings with it some very peculiar and fascinating consequences. If space is truly without end, then the amount of matter it holds is likely infinite as well, or at least so staggeringly large that it might as well be. This implies an endless number of stars, planets, drifting comets, and clouds of cosmic dust, and yes, potentially even the spark of life itself. Somewhere out there, in the farthest reaches of a never-ending cosmos, there might be another planet just like our own Earth. Perhaps it has trees that grow sideways toward a different sun, or oceans that sparkle with colors we have never imagined. Maybe it is home to creatures who are asking the same questions we are, wondering if their universe ever comes to a stop. Here is where the story starts to bend the mind just a little, for in an infinite universe where matter is spread more or less evenly, the laws of probability suggest that patterns will eventually repeat. This means that somewhere in the vastness, there could be a version of you, or perhaps several. Some might be nearly identical, while others might have chosen a different breakfast cereal this morning, and accidentally altered the entire course of their day. There is no need for this thought to be unsettling, for you are not going to bump into your cosmic twin at the grocery store. These regions are likely so far away that they remain forever unreachable, as the light from those parts of space will never find its way to our shores. Even if we waited longer than the age of the universe multiplied by every grain of sand on our planet, that light would still be on its lonely journey. Still, the implications of such a thought are profound, for infinity is not just a matter of size, but a shift in the way we think. It transforms the universe from something that is merely large into something that is truly boundless. You no longer have to wonder what lies beyond the edge of the map, because there is no edge, only more maps stretching on forever. Of course, our scientists remain cautious about assuming the universe is infinite, for we have only a finite sample of reality to work with. It remains possible that space is very large but still finite, curving gently back on itself in a way we cannot yet detect. It might loop through higher dimensions, or form a shape more exotic than any we have ever dreamed. There is also the question of time, for the universe might be infinite in its reach but finite in its duration. It had a beginning in the Big Bang, and while the notion of a beginning is itself a slippery idea, it suggests the cosmos has not always existed in its current form. Philosophically, the idea of infinity challenges our relationship with the world, for most things in our daily lives have limits. Our time, our energy, and even the number of cookies in a jar all come to an end. But infinity breaks that mold. It removes the boundaries and opens up a playground of endless possibility that can feel both inspiring and overwhelming at the same time. Some ancient thinkers like Aristotle were deeply uneasy with the idea of infinity, believing the universe had to be finite because actual infinities were too strange to accept. Even today, the debate continues over whether true infinities can exist in the real world, or if they are just useful abstractions for our math. But whether or not the universe is infinite, there is a deep value in contemplating its vastness. It stretches the mind, invites a sense of humility, and reminds us how small our perspective truly is. When you look up at the stars, you are peering into a mystery so immense that our boldest measurements barely scratch the surface. You are seeing only a local glow, a few lights shining in the window of a grand cosmic mansion. Yet, here we are, tiny creatures on a spinning planet, wondering how far the space goes. We build instruments to chase after ancient light. We invent mathematics to frame the impossible, and we lie awake at night thinking about what lies beyond the last star we can see. Maybe the universe is infinite, or maybe it is not. But either way, it is more than enough. It is more than enough to fuel our questions, our stories, our science, and our dreams. It is enough to remind us that we are part of something truly immense and beautiful. And the most wonderful part of all is that you do not have to know how far it goes to feel perfectly at home within it. You are already woven into its very fabric, a flicker of thought on the edge of the observable, glowing softly in a cosmos that may never end. There's something truly irresistible about the idea of an edge, for we grow up surrounded by walls, fences, sidewalks, and even lunchboxes. Everything we encounter in our daily lives seems to stop somewhere. So when we think about the universe, it is only natural to imagine it must stop too. Surely, after some truly staggering distance, space must come to a final end, like the last room in a very big mansion, or the edge of a massive tabletop hanging over the abyss. But here's the twist, for space does not actually need an edge to exist. It can be finite in its size without having a boundary at all. And that is where things get beautifully strange. Let us start with something simple, and picture the surface of the earth beneath your feet. If you were to walk in a straight line in any direction, you would eventually circle back to exactly where you started. You would not fall off anything, you would not hit a wall, and you would never find a signpost reading "End of Earth. Please turn around." The surface is finite but unbounded, looping back on itself in a seamless and graceful way. Now, take that idea and expand it to a three-dimensional space, and imagine living inside a volume of space that wraps around itself in much the same way. If you could keep moving forward in a perfectly straight line through this space, you might eventually return to your starting point, having never encountered a wall, a cliff, or any kind of edge. This kind of space is not science fiction. but a perfectly valid model in cosmology, known as a finite, unbounded space. It sounds like a paradox at first, like saying a cup can be full of tea, but not contain any liquid. But once you understand the geometry, it clicks into place. Space can be shaped in such a way that it closes in on itself, forming a complete volume without ever needing to come to an end. One of the classic shapes used to illustrate this idea is the torus. So imagine a donut, not the jelly-filled kind, but the smooth round kind with a hole in the middle. The surface of the donut is two-dimensional, and you can walk around it without ever leaving the surface, yet it has no edges. It loops back on itself both horizontally and vertically. And if you were an ant walking on its surface, you could go forever without ever hitting a boundary. Now, imagine a three-dimensional version of that, where space loops in multiple directions at once. This does not mean the universe is shaped like a pastry, but the torus helps us visualize how space might behave if it were finite and without a border. You could start at one point in space, travel in a straight line, and after a very, very long time, find yourself right back where you began, like a galactic boomerang. Another helpful analogy comes from the world of video games such as Pac-Man or Asteroids, where if you move your character off the edge of the screen on one side, they reappear on the opposite side. It is not that there is an invisible tunnel. They have just looped around on a map that wraps back on itself. These are two-dimensional versions of a toroidal space, where the game world is finite in size, but the edges do not behave like real-world walls because they connect. In theoretical cosmology, this idea is more than just playful musing. For some models propose that the universe could have a topology, a fundamental shape that loops back in subtle ways. We might not notice these loops unless we look far enough, and in just the right direction. There has even been speculation that if the universe is small and curved just right, we might see repeated patterns in the cosmic microwave background, like mirrored wallpaper left behind from the Big Bang. So far, we have not found any clear signs of this repetition, but the idea has not been ruled out completely. The deeper truth is that the universe does not need an outer surface or a surrounding void, for that is a very human way to look at space. We often imagine the universe as something sitting inside something else, but space is not a thing embedded in a larger thing, for it is the thing itself. It is not like a colorful balloon floating in the air. It is more like the entire balloon itself, with all of us held upon its surface, unable to step outside and look back in. Even if the universe is infinite, it still does not require an edge to be real, for infinity is not a place, but a property. Saying the universe is infinite is like saying that numbers never stop. You do not need to find the last number to know that one does not exist. And likewise, you do not need to locate the edge of space to know there might not be one. Edges also create deep philosophical headaches, for if there were an edge, what would be beyond it? More space, or something else entirely? Would it be a blank nothingness that sits awkwardly waiting to be defined? The moment you introduce an edge, you introduce a paradox. If there is something beyond, then space has not really ended. And if there is truly nothing, then how can it be said to exist at all? By contrast, a universe without edges avoids this confusion entirely. It just is. You can keep moving forever, or you may come full circle, but there is no edge to fall off, no cosmic warning signs, and no need to define what lies beyond the beyond. This does not mean we will never stop asking about boundaries, for our brains are wired to think in terms of containers, and we like our beginnings, our middles, and our ends. But the universe does not seem to care much for our mental filing cabinets, as it stretches, curves, and possibly loops, all without offering a clean border to sign off on. Interestingly, even if space has no edges, time might, for our universe had a beginning, at least from our perspective, with the Big Bang around 13.8 billion years ago. That is not a point in space, but a point in time, a moment when space itself began expanding from an earlier state. Asking what came before the Big Bang is like asking what is north of the North Pole. It is not that the question is meaningless, it is that our usual coordinates simply stop working. All of this paints a picture of a universe that is far more subtle and strange than a giant box. It is not an object you can lift the lid on or peek around the side of. It is more like a melody that plays itself forward, wrapping around dimensions and humming through time with no final note, no ending chord, just an endless variation. In that melody, there are no hard edges, only connections, curves, and continuations. Whether it loops or stretches infinitely, the universe does not close off like a room. It opens up like a beautiful idea. It is not bounded by walls, but shaped by relationships, by gravity, light, motion, and time. So if you have ever imagined a spaceship sailing bravely toward the edge of the universe, picture instead a long and quiet journey that never finds a cliff, but only more stars, more questions, and more space. This is not because the universe goes on forever necessarily, but because it never had an edge to begin with. Before there were stars, before there were galaxies, and even before atoms had properly settled into their roles, there was a glow. This was a soft and uniform light spread across the universe like a warm fog, stretching in every direction. It was not a spotlight or a fireworks show. It was quieter than that, gentler, like the first rays of dawn seeping through a window before anyone has had a chance to open their eye. Some of that light is still with us today, and we call it the cosmic microwave background. It is not just the oldest light we can see. It is the oldest light anyone can see, a whisper from the very early universe, still drifting gently through space. It passes through galaxies, stars, planets, and sometimes, with the right instruments, into our detectors. To understand where this light comes from, let us go back in time, way back, to about 13.8 billion years ago. The universe began in a hot and dense state, a singularity of seething energy and unfathomable temperature. In its earliest moments, space expanded rapidly, spreading out the energy like batter in a pan. As the universe grew, it cooled steadily, like a cosmic kettle, slowly taken off the stove. At first, the universe was a blinding soup of particles and radiation, where photons bounced around constantly, trapped in a fog of charged particles. Electrons and protons whizzed around separately, and light could not get very far before being scattered in a new direction. Imagine trying to shine a flashlight through a dense and heavy cloud, for that is what the universe was like for its first few 100,000 years. Opaque, chaotic, and full of restless motion. But then something magical happened. About 380,000 years after the Big Bang, the universe cooled enough for protons and electrons to combine into neutral hydrogen atoms. This moment is poetically called recombination, and it changed everything. With fewer charged particles to scatter off, light was suddenly free to travel, and the fog lifted. The universe became transparent, and the first light broke loose, set free across the cosmos to travel ever since. It fills the universe in every direction, stretched out by billions of years of cosmic expansion. And though it was a searing blast of ultraviolet energy, it has now cooled to a gentle microwave hum. It is a whisper instead of a roar, but it is still there all around us, passing through your room this very moment like a soft, invisible breeze from the beginning of time. We first discovered this cosmic light almost by accident in the 1960s, when two radio astronomers named Arno Penzias and Robert Wilson were using a large horn-shaped antenna to study radio signals. They kept detecting a persistent background noise, no matter where they pointed their antenna, so they cleaned their equipment and double-checked their math. They even removed some pigeons nesting in the device, just in case it was their fault. But the noise remained steady, uniform, and strangely cosmic. What they had stumbled upon, without realizing it at first, was the afterglow of the Big Bang, the cosmic microwave background predicted by theory and now detected in all its subtle glory. That faint hiss on their radio signal turned out to be a window into the infant universe. And since then, scientists have mapped this light in astonishing detail. Space missions like COBE, DimMap, and the Planck satellite have given us a high-resolution picture of this ancient light, revealing it as a cosmic blueprint. It is a snapshot of the universe when it was less than 500,000 years old, and though it looks uniform at first glance, it is filled with tiny fluctuations. If you zoom in closely, you see little warm and cool spots, just a few millionths of a degree different from each other. These gentle ripples are not imperfections, but the seeds of everything. Tiny differences in density that over billions of years would grow into stars, galaxies, and eventually you. Those slight variations are clues that tell us how matter was distributed in the early universe, revealing the physics of the cosmos at its birth. Even the shape of the universe leaves its fingerprints on this ancient glow. For if space were curved like a sphere or a saddle, those geometries would subtly distort the way light travels. By measuring the size and distribution of these fluctuations, scientists can infer the large-scale structure of space itself. So far, all signs point to a universe that is flat, at least within the limits of what we can observe. It is a bit like looking at the pattern of waves on a pond to figure out the shape of the shoreline, for the way those ripples stretch and move carries information about the environment they travel through. The cosmic microwave background carries encoded messages about the shape, size, and ingredients of the universe, acting as light as data and photons as historians. There is something deeply soothing about imagining that glow, a soft and gentle wash of ancient light that is not blinding or fiery, but calm and even. It is not one that you can see with your eyes, but it is always present, like the universe's own lullaby still playing after all these years. If you could tune in with the right kind of radio, you would hear it everywhere, not as a song, but as a faint static warmth woven into the very fabric of space. It is the closest thing the universe has to a baby photo, a snapshot of its earliest moment of clarity, still whispering to us long after the stars were born, long after galaxies spun into shape and Earth began its slow dance around the sun. That light has outlived generations of stars. It has crossed unimaginable distances to arrive here in your lifetime, ready to tell its story. In a universe filled with mystery, this glow is something solid that we can measure, map, and understand. It reminds us that we do not need to chase the edges of space to learn about its beginning, for the answers are already floating all around us, waiting patiently in the light. So the next time you look up at the night sky, try to picture it not as black and empty, but filled with an ancient light too faint to see. It has been traveling for over 13 billion years, stretching with every passing moment and carrying the quiet history of everything. Even now, in the stillness of space, it continues to shine as we wonder if there is a true edge to the universe, or a final frontier. It is a question that keeps bubbling up, whispered between chalkboards and telescopes, as we search for that ultimate boundary where space might just stop. While the mainstream of our understanding leans toward a universe with no hard edge, there are whispers of speculative theories that nudge open the door to stranger possibilities. These are places where boundaries might exist, even if we cannot quite see or feel their presence with our current senses. Let us start gently, with the idea that our three-dimensional world could be a kind of surface or membrane, floating within a much higher dimensional space. This is one of the central thoughts in brain cosmology, where our entire universe is imagined as a vast three-dimensional bubble, or brain, existing within a higher dimensional bulk. We are confined to this specific brain, and all the particles and forces we know, except for gravity, are stuck here like tiny bugs trapped on the surface of a soap bubble. Gravity, being a bit more adventurous and mysterious, might leak into the surrounding dimensions, which is one reason why it seems so weak compared to the other forces of nature. If this idea is correct, then our universe could indeed have an edge, not in the 3 dimensions we know, but in the higher dimensional bulk we cannot perceive directly. From our point of view, everything seems continuous and beautifully edge-free, but from the perspective of a 5-dimensional being with excellent vision, we might look like a cosmic disk with boundaries at the rim. It is a little unsettling to think of being watched by something with more dimensions than we can comprehend. But there is comfort in it too, for we would be the strange mystery to them. Next, we might consider the idea of cosmic domain walls, which are boundaries between different regions of space where the laws of physics might be slightly different. These walls are predicted by theories of symmetry breaking in the early universe, much like water freezing into ice. Imagine that space went through a phase change, but it did not freeze the same way everywhere, leaving some regions with one set of rules, while others chose a different path. The borders between these patches could form massive domain walls, stretching across space and dividing one cosmic regime from another. In most models, these walls would have disappeared long ago, but some imagine they could still exist, lurking in deep space like silent sentinels. Passing through one might be undramatic, or it might be like stepping into a parallel universe where your atoms behave just a little bit differently, and perhaps your tea tastes slightly more lemony for no apparent reason. Some thinkers have also wondered whether our entire universe might be the inside of a literal bubble, formed during a phase of cosmic inflation. Picture the early universe, frothing with quantum fluctuations, and in some regions, inflation stops to form a bubble of space with its own unique constants of nature. This leads to the idea of a multiverse, a foam of bubbles where each one is a universe unto itself with its own gravity and dimensions. This is sometimes called eternal inflation, and suggests there is a kind of edge where our bubble meets the inflationary background, or perhaps another bubble in the foam. Such collisions would be beyond rare, for our neighbors would be too far away to ever meet, making the edge of our bubble more theoretical than tangible. There is a strange poetry in imagining the universe as part of a fizzing sea of other realities, each expanding into the void like soap on a dish. Finally, we encounter the rotating universe of Kurt Gödel, the same thinker who touched the very limits of mathematics. In 1949, he found a solution to Einstein's equations that described a universe rotating as a whole, where the entire fabric of space-time twists like a vast cosmic spiral. In this strange model, space and time are curved in such a way that you could, in theory, travel along a path and arrive back at an earlier point in time. This would be a time loop, blurring the line between the boundaries of space and the boundaries of cause and effect. One might wonder which is more disorienting, a wall at the end of the universe, or the ability to meet yourself before you were born. While our observations show that our universe is not spinning in this global way, the model remains valuable because it stretches our minds and challenges our instincts. These thoughts remind us that the rules of the universe are not set by the reach of our imaginations, but by the silent elegance of equations. And those equations at times allow for worlds that are far stranger than any fiction we could ever write. Another wild and captivating idea proposes that the universe might be like a hologram, though not in the flickering sense of a projection. According to the holographic principle, everything that happens in our 3-dimensional space might actually be encoded on a distant, 2-dimensional boundary. It is much like the way a flat surface can store a full, deep image, suggesting that the true edge of our universe is not a wall, but a boundary where fundamental information is kept. This idea emerging from the depths of string theory and the study of black holes, is still speculative, yet it remains a tantalizing glimpse into a different way of describing our reality. The deeper message behind all these theories is not that we will find a physical wall at the edge of space, or a sign that reads, "End of universe. Authorized personnel only." Instead, it suggests that space might have limits and boundaries in ways that do not look like anything we are used to in our daily lives. Edges might exist in higher dimensions, in the initial conditions of our birth, or in the very information that underlies everything we see. They might not look like walls at all, but might appear as changes in physics, changes in curvature, or changes in the rules themselves. It is entirely possible that we live in a universe with no edge at all, but it is also possible that we are brushing up against ideas that feel like edges, limits of what we can know, observe, and describe. We are creatures who have evolved to live in rooms and on continents, surrounded by air and gravity, and things that eventually come to an end. So when we step into the vastness of cosmology, we naturally bring those instincts with us, searching for edges because everything else in our life has them. But the universe is under no obligation to follow our human expectations, and it may loop quietly in on itself, or stretch infinitely in every direction. Perhaps it perches delicately on the surface of a higher dimensional bubble, or is shaped like something we have never thought of before, something that curves and connects in ways our minds can barely begin to grasp. There is something deeply peaceful in the thought that the universe could be endless, not just in its size, but in its very possibility, that even our questions themselves might stretch on forever, offering us a big enough challenge just to understand the billions of galaxies and swirling black holes we can already see. We have plenty to ponder with our cosmic background radiation in space that curves and stretches, yet every now and then, the thinkers of our world like to ask an even bigger question. They wonder if this universe is truly the only one, welcoming us to the fascinating and bizarre realm of the multiverse hypothesis. This is one of the most thoroughly speculative ideas in modern physics, suggesting that there might be more than one universe, perhaps even infinitely many. It imagines universes with different physical laws, different particles, and entirely different timelines, where gravity might flow sideways, or your past choices turned out quite differently. Before we go too far into this dream, we must be clear that there is no direct evidence for the existence of other universes, for we have not seen them or waved to them. Across a dimensional fence, the multiverse remains a framework, a way of thinking that arises naturally from certain theories, yet still lives firmly in the quiet land of speculation. The idea of other worlds, while it may sound like the whispers of a dream, is not as wild as one might first believe. In truth, there are several different versions of this multiverse hypothesis, each offering its own unique flavor of cosmic imagination. The first and most intuitive is the cosmic multiverse, often called the bubble universe model. This idea arises from the heart of inflation theory, that rapid swelling that occurred just after the dawn of the Big Bang. According to this view, inflation did not happen everywhere at the same pace, but instead could have created many separate bubbles, each forming its own independent universe. Each bubble might have its own secret laws of physics, where some are too strange to ever support matter, while others might possess entirely different kinds of particles, or even extra dimensions. We simply happen to live in one of the fortunate bubbles, where the conditions are just right for stars, planets, and the gentle flow of late-night thoughts. In this model, our universe is like a single soap bubble, floating in a vast cosmic foam, while other bubbles drift endlessly, forever separate from our own. If you are picturing a quiet sink full of soft dish suds, you are not far from the truth of this theory. Then, we encounter the quantum multiverse, which grows from the many worlds interpretation of quantum mechanics. This version suggests that every time a quantum event has multiple possible outcomes, all of them actually happen in separate, branching universes. In one universe, you may have hit snooze this morning and stayed in the warmth of your bed, while in another, you rose early to make pancakes. In yet another branch of reality, you might have tried to make those pancakes but accidentally discovered the secret to teleportation instead. Each branch is a new version of reality, created by the unfolding of every possible choice and every tiny chance. This is not merely a thought experiment, but a serious interpretation developed to avoid the complexities of how particles behave when we are not looking. Yet, like the bubble universe, it is not something we can currently test or observe, for we cannot jump between these branches. There is no interdimensional train station where a mustachioed conductor offers trips to the universe, where you became a world-famous harmonica player, and statistically speaking, in at least one of those infinite branches, you probably have a mustache, even if you have never grown one in this life. Somewhere out there, a version of you might be giving a grand talk about alternate facial hair and its impact on the parallel timelines of the soul. There is also the mathematical multiverse, a bold idea proposed by the cosmologist Max Tegmark. This is the suggestion that all mathematically consistent structures exist as physical realities, meaning that if it is mathematically possible, it exists somewhere in the vastness. This includes not just universes with different particles, but ones with entirely different logical rules, where the value of pi might be different or time might flow in a gentle spiral. It is a mystical suggestion, almost impossible to test, yet it is compelling to think that math itself could be the fabric of existence, spawning every possible variation of reality, like an infinite library of cosmic blueprints. These multiverse ideas, while deeply intriguing, do face their share of criticism. For science works best when we can test our predictions and measure the results. One of the biggest challenges is that if these other universes are forever inaccessible, it is hard to know if they truly exist at all. Some physicists see the multiverse as a sign that our theories are stretching beyond their useful limits, while others argue it helps explain why our universe is so perfectly tuned for life. If there are countless universes, each with its own laws, it is not surprising that we live in one where existence is possible. It is a cosmic version of survivorship bias, where we exist here simply because this is a place where existence can thrive. It is like rolling dice in a casino with an infinite number of tables, where most tables produce nothing of interest. But at one of them, by pure chance, the dice land just right, and that is the table where we are sitting. We did not rig the game or cheat the system, we just happened to be in the room where the numbers worked out in our favor. Some cosmological models even suggest that multiverses might be indirectly detectable, perhaps through unusual patterns in the cosmic microwave background, caused by ancient collisions between bubble universes. So far, nothing has shown up in our maps of the sky, but physicists are keeping a very open mind, for some of the most incredible discoveries in science started as strange ideas waiting for the right tools. Whether or not other universes exist, pondering them stretches our imaginations and encourages us to think beyond the limits of what we can see. It reminds us that reality might be far broader, stranger, and more playful than we ever expected, inviting us to be humble in the face of what we do not know, and bold in exploring what we might someday learn. And really, that is what science is all about. Not just answering questions, but discovering even bigger ones. And not just building knowledge, but expanding the sense of wonder. Even if we never find another universe, even if this one is all there is, We've already proven that human curiosity can reach across galaxies, through time, and into ideas as vast as the multiverse itself. That is no small thing. So whether you believe in a single cosmos or an infinite stack of them, remember that somewhere in the multiverse, you are doing something brilliant, or unusual, or inexplicably involving a llama. And in this universe, you are here thinking about space, sipping your tea, and quietly wondering what else might be out there just beyond the veil of what we know. That in itself is a kind of cosmic magic. But the question of where space stops has brought us here, whispered softly at the beginning like a child, asking if the sky has an end. After wandering through galaxies, curved dimensions, and the edges that may or may not exist, we find ourselves gently circling back to where we began, still wondering. We have learned that space does not behave like a room or a box or a stretch of road, and it does not come with a fence or a finish line. It does not need walls to be complete, and it can be infinite or finite and unbounded, stretching, looping, curving, and folding in ways our minds are only beginning to understand. It can even carry galaxies away from us faster than light, not because they are moving, but because the space between us is growing. We know that there is a limit to what we can observe, a cosmic horizon beyond which light has not yet reached us, but we do not know what lies beyond that. Maybe the universe keeps going forever, or maybe it folds back on itself in a gentle arc we will never see, perhaps drifting as one bubble among many in a higher dimensional sea. What we do know is that space is not empty. It is alive with structure and subtle energy, stretching with time and carrying the light of ancient stars. It has no center, and as far as we can tell, no end. Yet the questions remain, asking if the universe is infinite or just very large, and whether it is one of many or all there is. We may never find all the answers, but that is not a failure. It is the very heartbeat of science. The beauty of the cosmos is not just in what we know. It is in what we do not, in the quiet courage of looking up and asking. The search continues as it always has, through telescopes and equations, through gentle dreams and midnight thoughts. Every photon we catch and every map we make brings us a little closer, even if the destination keeps shifting like the stars. Maybe that is the whole point. And maybe space never stops because it is infinite in mystery, not just in size. It does not have to end for it to matter. It just is. Sprawling quietly in all directions as an invitation rather than a boundary. I hope by now you feel more relaxed, and I hope your thoughts have softened into that quiet space where wonder lives. If you are still awake, just barely, I hope you found some peace in the asking. For that is what space truly gives us. It gives us the freedom to ask the biggest questions of all. And perhaps space never stops because our questions never do.